All right, so one of the questions I'm sure that comes to mind is, does every function have an inverse? Or in this case, we also want to know, if it has an inverse, is it also a function? And to determine that, we have what we call the one-to-one tests. So we have the horizontal line test. We have always increasing or decreasing. And we have a mapping, be able to discuss a mapping between the domain and range. And these are ways we can determine if our inverse is a function or not before we even actually find the inverse. So let's start over here with the horizontal line test. So if my graph looks like this, you can see I could draw a horizontal line anywhere through here, and it only crosses my graph once. This is very much like the vertical line test we use to determine if something was a function or not. So you can see that as I move my horizontal line up and down, it'll only cross my graph at one place at a time. So then this one here, this one would be then one-to-one. In other words, if I take the inverse of this function, there is an inverse that will also be a function. And then let's pick one. Let's say I graph this. And you can see right away, well, here's my horizontal line. Of course, it crosses in two places. So that means that this one here is not one-to-one. So you may have an inverse. In fact, you will have an inverse of that, but it won't be one-to-one. In other words, the inverse will not be a function. Another way you can tell quite quickly, let's go back to that. So, if I just have a line here that's always decreasing, of course, the horizontal line will only cross at one time. But if I have a line that is not always increasing or decreasing, so for example, like this, you can see now if I draw a horizontal line here, that it crosses 3 times because, yes, we're increasing, but now we decrease. Increase, decreasing. See another horizontal line right here, we cross multiple times. So this one here is one-to-one because it's always decreasing. This one here is not one-to-one because it's not always increasing. So again, if you're looking at the graphs, it's pretty quick and easy to decide if what we have is one-to-one. Now let's talk about the domain. And again, this is very much like finding functions. So let's say that 3, you put in a 3 and it gives you a 1 out. You put a 5 in, it gives you a 4 out. Put a 6 in, gives you a 2 out. 8 in, gives you a 7 out. This is easy to see where we get the name one-to-one. Put in one value in, you get one value out. So this here would be one-to-one. But of course, if I were to change this just a little bit, so that if I put in a 5, I also get a 1 out, then we'd say this is not one-to-one. Okay, so let me erase the board and I'll give you one more example on how we can determine if something is a one-to-one. All right, so let's check if these functions are inverses in 3 different ways, just kind of as a wrap up. So I want to run through the 3 main methods on this. So the question is this an inverse of this and vice versa? So first way is what we can do is find the inverse of this and see if it is in fact that. All right, so let's just start right here. I'm going to start off with making this y equals x minus 3 over x plus 4. There's a little bit of a trick right here. We can cross multiply here. So I end up with y times x, or xy, and then y times 4, so 4y, equals x minus 3. And now let's do that.